Hi, welcome. We're at the MPI booth at European Microwave 2023 in Berlin, and we're introducing at this conference the first integration of a automated prober with a thermal imaging system. We have integrated thermal camera with quarter micron space resolution and 50 nanosecond temporal resolution into the automated prober, so we can do pulsed thermal measurements and pulsed electrical measurements without switching to a different dedicated system. So let's see. Okay. With MPI, Microsanj has integrated their detector as well as high magnification objectives, and we have a motorized mount so that we can switch from low magnification for probing or for searching for defects or failures or hotspot locations, and then we can switch to a higher magnification to actually measure the temperature inside a channel of the transistor. So now, as you do your electrical measurements, you can now add a thermal component into your testing, your automated tests, and have a whole other parameter to measure for all of the performance of the device. So after we bias and probe with the MPI solutions, we can acquire thermal images, and then we can process the temperature profile, or we can look at the maximum temperature of the transistor. So this is at the high magnification, where right now it's at a 50x magnification, and we can switch to a lower magnification if we want to do probing, or if we want to do just larger temperature distributions. With the motorized objective, we can do the probing at low magnification or thermal measurements at low magnification to get the overall temperature distribution. And if we want to zoom into the channel, we can then use the motorized turret to switch between the low magnification 20x lens to a high magnification 50x with long working distance. And then we also have the option of adding a separate low magnification infrared detector, so we can do infrared measurements. So at Microsanj, we specialize in thermal reflectance measurements in order to get the high speed of 50 nanoseconds and the high spatial resolution of a quarter micron. But at low magnification, for looking for failures, if you're trying to look at for hotspot location, you can use the microbolometer infrared detector with 5 microns of resolution in order to do searching and get very high sensitivity. This is showing the low magnification 20x objective, which we can use for probing and finding the part in temperature distributions on a larger scale. And then we can switch to the high magnification to 50x objective to get temperature measurements down to quarter micron inside the transistor channel.